I am Mr. Gant. Project Management. Welcome to PM101, Module Number 2. Forward and Backward Pass CPM Calculations. Good day, everyone. This session will go through the forward and backward pass calculations, also known as the CPM critical path method scheduling technique. The two key items that we create and compute from the CPM forward to pass operation are: the forward to pass procedure calculates the earliest dates from the start to the end of each activity in your project. The second specifies how long your construction projects must last, or the minimum duration. While the backward pass process, on the other hand, determines the late dates from the latest start to the latest finish of each construction activity or task that can be performed, while not increasing the construction project's minimum duration that was identified in the first forward to pass calculation. Let's look at an example from the forward and backward to pass computation. As you can see on the left side above, here the key emphasized the early dates, early start and early finish, as well as the late dates, late start and late finish. In the right side is the mathematical equation for the forward and backward pass. Activity A. Here is the initial activity where we'll begin the forward task calculations of the project. Let's begin the early start to be equal to 0. For activity A, we have 6 days duration, so 0 plus 6 equals 6 for the early finish of activity A. So, we must consider activity A, early completion, to be equal to the early start of its successor activities, which is activity B and C. In this scenario, activity B, the early finish, will be the early start 6 plus 2 equals 8. The same is true for activity C, the early finish, will be the early start 6 plus 8 equals 14. For activity D's early start, we have two predecessors, activity B and C. So the link indicates that once activity B and C are completed, we can begin activity D. Also, as you can see, in the mathematical equation, we get the maximum number between all the predecessor activities of early finish, which is 14 in activity C. Then, lastly, early finish of activity D will be 14 plus 5 equals 19. So, we already completed the forward to pass calculations to determine the earliest time we start an activity and earliest time we finish an activity. Secondly, we determine the minimum duration of the project, which is 19 days. Next will be the backward pass. Let's proceed to understand the backward pass computations. When you finish the forward to pass calculations and begin the backward pass calculation, you always take the last activity. The only connection between the forward to pass calculations and the backward pass calculations, as we can see from the top right, is the early finish date, which is the minimum duration of the project we have, which is day 19, and that number we will take to be the late finish date of the last activity. The late start date of activity D will equal the late finish date of activity D, 19, minus the duration, 5, so in this case will be 14. The late start date of activity D will be equal to the late finish date of both activity B and C. So both activity B and C will be 14 for their late finish date. The late start of activity B will be the late finish, 14, minus the duration, 2, equals 12. The late start of activity C will be the late finish, 14, minus the duration, 8, equals 6. The late finish date for activity A. We took 6 because if we want to look at the mathematical point of view, it's the minimum of the late start date of both activities B and C. Lastly, we subtract 6 to 6 to go back to 0. This completes our backward pass calculations. Let's answer this exercise. Instruction is to draw the network and perform the CPM calculations. First, let's draw the network. First, activity A and activity B with 6 and 2 days duration respectively. As you see, it has no assigned predecessor. Let's add a project start milestone to connect the two activities. Activity C with 8 days duration, linked finish to start to activity A. Activity D with 5 days duration, linked finish to start to activity A and activity B. Now, activity E with 3 days duration, linked finish to start to activity B. Next, activity F with 6 days duration, linked finish to start to activity D and activity E. Activity G with 5 days duration, linked finish to start to activity C and activity D. Lastly, activity H with 4 days duration, linked finish to start to activity F and activity G. That completes our activity on node network. Next will be our forward pass and backward pass calculations. Let's solve the forward pass calculations. Let's start with 0 in project start milestone. On activity A, early start will be 0. Activity A, early finish, will be the early start, 0, plus the duration 6, equals 6. On activity B, early start will be 0. Activity B, early finish, will be the early start, 0, plus the duration 2, equals 2. Activity C, early start, will be the early finish of A, which is 6. Activity C, early finish, will be the early start, 6, plus the duration 8, equals 14. Activity D, early start, we have 2 predecessors. We will wait both to finish, and the maximum of the 2 will be 6. Activity D, early finish, will be the early start, 6, plus the duration 5, equals 11. Activity E, early start, will be the early finish of B, which is 2. Activity E, early finish, will be the early start, 2, plus the duration 3, equals 5. We go to activity G, early start. We have 2 predecessors. We'll wait both to finish, and the maximum of the 2 will be 14. Activity G, early finish, will be the early start, 14, plus the duration 5, equals 19. Next is activity F, early start. We have 2 predecessors. We'll wait both to finish, and the maximum of the 2 will be 11. Activity F, early finish, will be the early start, 11, plus the duration 6, equals 17. Activity H, early start. We have 2 predecessors. We'll wait both to finish, and the maximum of the 2 will be 19. Activity H, early finish, will be the early start, 19, plus the duration 4, equals 23. This completes our forward pass, and the minimum duration of the project is day 23. Let's start the backward pass calculations. Activity H, late finish, will be equal to our early finish, which is 23. Activity H, late start, will be late finish, 23, minus the duration, 4, equals 19. Activity G, late finish, will be equal to Activity H, late start, which is 19. Activity G, late start, will be late finish, 19, minus the duration, 5, equals 14. Next is Activity F, late finish, will be equal to Activity H, late start, which is 19. Activity F, late start, will be late finish, 19, minus the duration, 6, equals 13. Activity C, we have only one successor, so late finish will be 14. Activity C, late start, will be late finish, 14, minus the duration, 8, equals 6. Activity D, late finish, we have two successors, the minimum of the two will be 13. Activity D, late start, will be late finish, 13, minus the duration, 5, equals 8. Activity E, we have only one successor, so late finish will be 13. Activity E, late start, will be late finish, 13, minus the duration, 3, equals 10. Let's have Activity A, late finish. We have two successors. The minimum of the two will be 6. Activity A, late start, will be late finish, 6, minus the duration, 6, equals 0. Lastly, Activity B, late finish. We have two successors. The minimum of the two will be 8. Activity B, late start, will be late finish, 8, minus the duration, 2, equals 6. Back to our project start milestone, we have two successors. The minimum is 0. This completes our forward and backward computations. Thank you very much.